Trying to start a fight and go home early. So
Yes, let's go.
I gave you all even sum. All right, let's just go to problem number 1 first. Is that okay? And I just want to verify that we did okay with it. You write down, jot any notes down you need to jot down, okay? Okay, so we have 2 linear equations. Agree? All right, so let's insert a, nope, let's go to math. And I want to put a graph, a Cartesian graph. Okay. Let's graph these, see how we do. Is this solid or dotted? Dotted, everyone feel good about that? And I have a y-intercept of -3. And I'm going to go up 1, right 2. And then up 1, right 2. Keeps going. Now, someone asked the other day, why did I keep going? Because it's a continuous line. So dotted, right? So talk to me, where does 0, 0 exist with this line right now? It's above, kind of to the left a little bit. That's okay terminology? Okay, what about this line? Is it solid or dotted? Solid. Solid, okay, and I can use what method to graph this one? Cover method, so x equals 2. Y equals 1. And you said solid line, right? So we can indeed see that these 2 lines intersect, but with these we weren't worried about the actual point they intersected, right? We were worried about where to shade. So in reference to the purple line, where does 0, 0 live? Down to the left? Is that okay? Okay, so 0, 0 is a good test point for us to use. It's the easier one to use, so we're going to test that point. So we're going to try and plug 0, 0 and see what happens. So if I plug 0, 0 into this top equation, I'm going to get 0 is less than 0 minus 3, which is -3. Is that true or false? That's false. Okay, so let's go ahead and do the shading with that to make sure we can do it. We'll do it in yellow. So that gave us a false statement. So talk to me about where I am shading in reference to the blue line. I'm going below it. Good. So below this blue line, I'm going to shade. Try and make it as satisfying as always. Cool? Now, so our answer to this is either going to be down here or this little region here. But we have to check that other test point, right? So I'm going to check my test point here. So I plug 0, 0, and I get 0 plus 0, which is 0, is 0 greater than 4. That's also false, right? All right, so that's also false. Actually, I should probably use the blue. Let's use the blue on it. Okay. So talk to me about where we would shade in reference to the purple line. Above and to the right, correct? So this whole region up here, okay. So where does our graph exist? Where it's light blue, where it's yellow, or where it's green? Green. That's my solution. So this is my solution right here. I mean, and honestly, this is where our stuff exists in this region. I don't necessarily have to triangle it in, but when you are shading your stuff, you need to make sure that I understand you know where our feasible region is. Whether you have highlighters, you're able to do this, I don't know. Or you just kind of, shade a little bit. Does that all make sense? So problem number 2 would be done very similar. So how about I do problem number 3? Is that okay? Okay, so problem number 3, we have y is less than or equal to 1/2 x. Did you get it all done? Yeah? You're good? Thanks. Plus 2. And then I also have y is greater than -1/4 x minus 2. Those are my 2 equations. Agree? No doubt about those. We wrote them. So is one of them solid and one dotted? Okay. We all agree. One solid, one dotted. Let me bring up a Cartesian plane again for us. Cartesian. This should work. Let's see. Maybe I'll zoom out a little bit. Make sure stuff fits on there. Okay. All right. Let's take a look. Solid or dotted? Solid. Talk to me how I graph it.
Up 2.
Up 2. Okay, good. And then?
Up 1 over 2.
Up 1 over 2. Can I keep going?
Yes.
Sure. Just from each point, up 1 over 2. And you told me it was solid, right? It looks like that. Talk to me about where 0, 0 lives with this red line. Below it, to the right a little bit. Okay. All right. Solid or dotted? Dotted. Talk to me how to graph this one. -2, so I'm going to come down here, put a dot. And then down one end, right 4. I can go down 1 and right 4. Did you get it? Perfect. You ready for it? Yeah. Grab a Chromebook, and I'll get you logged in. Okay. Right on this problem, but I made one error. Anyone catch it? You didn't shade. Not yet. Before shading.
What is supposed to be dotted?
Which one's dotted? Red or blue?
The blue one.
The blue one. Yeah, so I made a boo-boo. Sorry about that.
Wow, Mr. Stora.
It happens.
People make mistakes.
Is that okay? All right, so 0, 0 is above to the right on the blue and below to the right on the red. Agreed? All right, so 0, 0 is still going to be a good test point because it doesn't affect either. So let's plug 0, 0 into this top one and see how it happens. So I get 0 is less than or equal to half times 0, 0. 0 added to 2 is 2. Is 0 less than 2?
Yes.
So that's true. So what does that mean with the red line? Do we shade above it to the left or below it to the right? Below it to the right. All right, so let's go ahead and put a highlighter on this.
Wait, so if it's true, do you always shade below it?
Well, you shade where the point exists. See where the point exists on the red right here? So we're going to shade that part. If it was false, you would shade the other side of the red. So I'm going to shade all of underneath the red. These are nice highlighters. They don't run out of ink. They don't smell.
I like the smell of ones.
What I always thought was funny is you remember when they came out with those markers that were scented?
Ah, I love those.
Yeah, but it's like one of the big warnings on Sharpies is don't smell it. But now I'm going to give you a marker to, I'm going to smell it. Bunch of morons in that company.
Does it kill your brain cells?
Supposedly. And being I only have 2 brain cells, I don't have too many left to kill. So.
That way you've been like sniffing pins and stuff.
Yeah.
Wait a second.
All right. I'm plugging 0, 0 into the blue, so I'm going to get 0 is greater than negative 1/4 times 0 is 0. 0 minus 2 is negative 2. Is 0 greater than negative 2? Yeah, it's bigger. It's to the right on the number line, right? Okay. Love it. Highlighter. Blue. That blue, okay? So where do I shade with the blue dotted line? Above it? Because that 0, 0 exists in this top region here. Anyone starting to see where our blue changed color?
Yes, sir.
What color is it changing to?
Green.
Yeah, buddy. And then it changes the color of our line a little bit, but that's okay. So which region are we talking about? Blue, green, or yellow? We good?
No, I don't get it. Why do we choose green?
Because where the 0, 0 existed was true on both my equations. So I'm going to make sure I shade below here because that gave us a true statement, and above here. So if it was just a singleton line, so if it was like the blue, this line right here, we shaded everything above that. And then on this one, we shaded everything below that. And the intersection that was above that and below, above this line and below this line is the green region. That's the shared region.
Okay, do we always highlight the
Shaded
shared region?
region is the one you want. So technically, I don't really want to have anything else shaded down here, but I do it because it changes color, and I think it's kind of cool to look at. All right? Good job cheering last time, by the way. Okay. I was at the basketball game.
Oh.
Cheer palms, I'm sorry. Cheer, right? Cheer. Okay.
Oh, yeah.
All right, so number 4 is going to be done similar. Is it okay if I do number 5? Go for number 5? All right, so number 5, we have 3x minus 2y. And that is greater than 6. And then I also have y is less than or equal to x minus 1. Both solid lines, both dotted lines, or one of each? One of each. Everyone feel comfortable saying that?
Yes.
Okay. Solid or dotted? Dotted. And then solid or dotted?
Solid.
Solid, okay. Let's bust out our graph. Let's see, both of those. I think both of those will squeeze on there. Okay, so let's do our red line first. How's the red line set up?
3x.
Cover method. So
Oh, yeah.
what's that? 2. So x is 2. And what's that? Negative 3, right? So negative 2y equals 6, so divide each side by negative 2. Cool. And that was dotted?
Yeah.
Talk to me about where 0, 0 is on this line. It's above to the left. Agree? Cool. All right, let's try this one. How do I graph this one? Yep. All right, thanks for coming in.
How did you get negative 3?
See you later.
How did I get what?
Negative
Negative 3, because I had negative 2y equals 6. So divide each side by negative 2. Negative 2 goes into 6 negative 3 times. That's where the cover method comes in.
I thought you just did 6 divided by
Ooh, I forgot to mark someone absent. Where's our friend?
Who's our friend?
Where's this one?
Oh, I saw her earlier.
Yes, go ahead.
So did I.
Glad to know. All right, green. Where does it cross the y-intercept? Negative 1. And then I'm going to do what? Up 1, right 1. And this is why I think if you continue plotting, what are you seeing? Is it going to cross it? Yeah, it did. Ooh. So we have like two skinny regions here and here, and then you got these big old fat regions. Is 0, 0 upper left on both of those? Okay. So 0, 0 is still a good test point for us to use. So I'm going to take 0, 0, plug it in here. So I get 3 times 0 minus 2 times 0, that's 0. Is 0 greater than 6? That's false, right? So if it's false, that's false. Talk to me about where I would shade in reference to the red line. Below it? Good enough? Okay. We okay so far? So we just did below the red on that one. Let's do the same thing with the green. I'll plug 0, 0 in. So I get 0 is less than 0 minus 1. 0 less than negative 1. That's also false. That's also false. So where do we shade in reference to the green line? Below it. So below the green as well. It's changing color, yes? So where's my solution? Yellow, blue, or green? It's green. So we just got a tiny little yellow region up there left and a skinny little blue region. That whole blue region. If I picked any points down here, I don't care what the ordered pair is. If they fall down in this region and I plug those in, I wind up with the true statement on both. Okay? But again, I use the 0, 0 as the test point because that's a really easy point to use. Everybody happy with that? Okay. And then 7 got kind of goofy, yes? You're like, dude, I got to make up the equation? So I have a graph. Let's see if I can make this graph the best I can. All right, so it looks like it crosses at -3 here. They're both solid lines, cool. And where else it crosses? It goes right here. Oh, it's right underneath it. It's right underneath it, right? It's right here. Is this it? Here? Is that it?
I think it's up to or to 2x in the equation.
Oh, I see. Okay, you want up to, right to. So I'm correct. If you look at the point, that's the point 2 comma 0, right? Oh, wait. No, wait. That's 1. That's 1. Oh, boy. I'm trying to just duplicate this. All right. So right there. Is that right? Feel good about that? Solid line, right? All right. That's a solid line. And then this one looks like it's at -5, I believe. Maybe -2, -4. Maybe about there. And then this over here was the region. It'd be better if I had it. Yeah. So we can see stuff. All right, so there you have shaded over here this region here. They don't have multiple regions shaded because you just want to know where it's your graphs would be true and true, correct? All right, We're still going to use 0, 0 as our friend. 0, 0 is still our friend. So the few things we can do, we're going to use y equals mx plus b because I can think on each of these, I can solve where across the y-axis. So where does this cross the y-axis? What's that? -3. And then this has a slope of up 1, 2, right 1. So my slope is 2 over 1 or just 2. Now I do need to change this sign, and I'll change that in a moment, okay? We have to make sure where it works. What's my y-intercept of my other line? It's -5. And it looks like my slope is down 1, right 2. So down half x. Okay? So those are my two equations. I have to change that as well. Everyone still with me? So I'm actually going to erase my equal signs on both. And I have to figure out what an inequality sign. I know that I'm going to have the equal thing because they're both solid, right? Get it? It's asking for just the b value. Okay, remember sometimes that b can be negative. So that's kind of the key right there. All right. So I'm going to use 0, 0 as a test point. 0, 0 right now, with where it's shaded, is going to be false on both of my equations. Agree? That makes sense if I say that? Because 0, 0 is not in our shaded region. So we got to figure out where it make it false. So if I plug 0 in, I get 0 is what to -3? What would make that false? Yeah, less than or equal to. Good. And then same thing here. 0, and that's a 0. So 0 is what to -5? So because I tested where they were, so 0, 0 is less than or equal to both of those. But remember I want to make these false. So what do I have to do with my two signs? I need to flip them. That would give me false. That would give me false. Good. Thanks, sir. That's a tougher problem, though. Oh, we missed it.
It's all Aiden's fault.
All right, and I'm going to skip the rest. All right, so what I would like you all to work on for tonight, and I want you to keep what we have because it's kind of your notes, and we'll hand it in tomorrow. So this is what you will hand in tomorrow. Okay, you'll hand in worksheet 5A, which my values are page 147 and 148. But then I'd also like you to work on worksheet 5B. Worksheet 5B, which is on page 149 only. Okay?
So can we keep 148?
Yeah, hold on. I will collect both of these tomorrow. Sound like a deal? That way you can utilize it as notes, and you can work on the page 149. Good to go? Yeah, this will be the new homework here. You get it? You could have walked in front of the camera.